In this video with circular motion, I want to introduce you to the vertical circular motion and specifics of it that you need to know. So the first question is not related to the vertical motion, but this is a specific video that I wanted to show you how to use vertical motion to solve circular motion. So the first question is going to be related to the formula that I mentioned in the previous video, where you have the centripetal force is your gravitational force. And if you remember from our dynamics videos, the gravitational force of between two objects that have masses is equal to g, the gravitational constant, m of one mass, m of the other mass, and the distance between them squared. So here is a satellite of mass 700 kilogram moves in a circular motion of the orbit 710 to the 7 meters away from Earth's center. What is the gravitational force on the satellite? What is the acceleration? And what is the speed of the satellite? So when I have to find the gravitational force between the satellite and Earth, I have to use the gravitational force formula, which is force of gravity is equal to gravitational constant g, the mass of the Earth, the mass of the satellite, and the distance between them squared. The gravitational constant, universal gravitational constant, is 6.7 10 to the negative 11. Then the mass of Earth, you don't have to remember this number, it's in the lessons. So this is 6 10 to the 24. And the mass of the satellite that they give you is 700 kilogram. And the distance between the satellite and the center of the Earth is 7 10 to the 7 meters squared. Now, if I calculate this number, I'm going to get 57.4 newtons. The next question, they ask you to find what is the acceleration. So it is a circular motion, so it's centripetal acceleration, and your gravitational force in this case is your centripetal force. And centripetal force is equal to AC, and m is the mass of the satellite. So I just found what the gravitational force is equal to, which is centripetal force, 57.4 equals to the mass of the satellite, 700, and then centripetal acceleration. So from here I can see that centripetal acceleration is equal to 0.082 meters per second squared. And the next question, they ask you, what is the speed of the satellite? So I know that centripetal acceleration is equal to v squared over r, and r is the distance between the two objects. So from here I can have 0.082 is equal to v squared. The distance between them is 7 10 to the 7. And now if I solve for the velocity, it's the square root of, I'm going to multiply both sides by 7 10 to the 7th, 5.7 10 to the 6. If I take the square root of this number, I get the velocity is equal to 2.4 10 to the third, or 2400 meters per second. Here's the first question with the vertical motion. So here is the vertical circle. And in this case, you have a 2 kilogram stone connected to the 1 meter long string. So 1 meter long string, 2 kilogram stone, and it is rotated at 4 meters per second. And they ask you to find what is the tension in the string when the stone is on the top and the bottom of the circle. So I'm going to draw a vertical circle, and then I'm going to show the forces acting on the stone on the top and the bottom. So if the stone is on the top, the forces I have acting on it is the force of gravity And another force acting on it is the tension force. And I also have centripetal acceleration toward the center. So I'm going to write Newton's second law, where I have the sum of all the forces, or the net force, is equal to ma. And in this case, it's a circular motion, so it is centripetal acceleration. So what I have here is this. The forces that are acting down, so both of them are negative forces. I have negative mg, negative tension, and equals to negative mac, because every single one of them is pointing down, and I'm going to choose negative direction down and positive direction up. And I'm looking for the tension, so I'm going to move tension to the right, and I'm going to move mac to the left. So I have mac minus mg is equal to tension, or I can rewrite it this way. Tension is equal to mac minus mg. So the tension on the top is going to be the difference between these two forces. Now, the tension on the bottom. So if an object is at the bottom, or the rock is at the bottom, the forces acting on it are mg, the force of gravity, and the tension force. And we also have centripetal acceleration because it's moving in circular motion, so there is a centripetal acceleration. And I'm going to use, again, the sum of all the forces is equal to mac. And the forces acting, tension is positive, and mg is negative. That's the sum of two forces. And equals to mac. AC is positive, so it's mac. Now, if I solve for tension, in this case, I have mg plus mac. And this one is at the bottom. So I have a different formula for the bottom part. If you see on the top, they will be, let me choose different color. The two forces are going to be subtracted, and at the bottom, the two forces are going to be added. And if you spun anything in a vertical circular motion before, you probably know that every time wherever you're spinning on the top in the vertical circle will feel lighter than it feels at the bottom. So at the bottom it feels heavier. The tension at the bottom is heavier, and the tension larger, and the tension at the top is less. So now I'm going to calculate the tension on the top, and then I'm going to calculate the tension at the bottom. But I need centripetal acceleration first. So I'm going to calculate centripetal acceleration first. It is v squared over r. V is 4. 4 squared is 16. And the length of the string is 1. So your centripetal acceleration is 16 meters per second squared. Now I'm going to plug in into my tension on the top. So the tension on the top is equal to, mass is 2 and acceleration is 16. So the mass is given 2, acceleration is 16. So I have 2 times 16 and minus mg, the mass is 2 and g is 10. So I have 2 times 10. So the tension on the top is 32 minus 20, 12 newtons. And if I'm looking at the tension at the bottom, I have mg, which is 10, mass is 2 and g is 10, plus mac, which is 32. So the tension at the bottom is 40. Sorry, this one was 20, right? Yes. So that is 52 newtons. UMG is 22 times 10. So this is an interesting fact, or the case where you have to look at the differences at the top and the bottom when the object is moving in the circular motion, and the circle is the vertical circle. Here's another example. I skipped some, so I want you to practice and try to solve them on your own, and you can see all these questions on our PDF online lessons. So here is number 27. 150 kilogram motorcycle is driven around in a 12-meter tall vertical circular track at a constant speed of 10 meters per second. And when they say 12-meter tall, that means the radius is 6. The radius is 6 meters. And they give you the mass of it is 150 kilogram, and they give you the velocity. And they want you to calculate the force at the 2 points that are labeled 1 and 2. So at first I'm going to do the top. So when I have the top, I have the motorcycle like this. And the force is acting on the motorcycle is the normal force. So the motorcycle is pushing on the track is pushing back on it. So this is the normal force. And also there is mg acting on it. So there is mg. And of course there is centripetal acceleration because it moves in a circular motion. So there is centripetal acceleration. And again, I'm going to start that the sum of all the forces, or the net force, is equal to ma, Newton's second law. And I have two forces, the normal force and mg. Both of them are negative because they're pointing down. So I have negative normal force, negative mg. And in my case, again, it is centripetal acceleration. So it equals to negative mac. And it's negative because acceleration is pointing down. And when they ask you to find the net force, they ask you to find, so this is your net force, your centripetal force. So your centripetal force is your net force, and equals to mass times acceleration. Mass is 150, acceleration is v squared over r, and v is 10 squared, and r is 6. So what we have is 15,000 divided by, instead of 6, I'm going to write 3 and 2. So what I have here is 15 divided by 3 is 5, and 1,000 divided by 2 is 500, and 5 times 500 is 2,500 newtons. And it is negative, right? So it's going to be negative 25 newtons, 2,500 newtons. And I also want to find the normal force. So the answers that you see there are normal force. So if I want to find the normal force, I'm going to solve for the normal force. And I have the normal force is equal to mac minus mg. And always pause it if you need more time to understand where I get what I get. So now if I plug in the numbers, MAC is negative 20, or actually 2,500, right? 2,500. Because when we move it to the other side, it becomes positive. Minus mg, and mg is 1,500. So that gives you 1,000 newtons. Now, if I look at the bottom part, the forces acting on the motorcycle would be mg, the normal force, and I have centripetal acceleration. Now, writing my equations, I have this. The normal force is positive, so I'm using again the sum of the forces is equal to ma. So the normal force is positive, mg is negative, and AC is positive, so I have MAC. So the normal force is equal to mg plus MAC. mg is 1500, 150 times 10. And MAC, we calculated in the black box right here. We just calculated it. It's 2500. So that is 2500. And that gives you 4000 newtons. So that's the normal force acting on the bike at the bottom of this vertical circle. Here's one more question. A popular daredevil trick is a complete vertical loop on a motorcycle. This trick is dangerous because if the motorcycle does not travel with enough speed, the rider falls off the truck before reaching the top of the loop. What is the minimum speed necessary for the rider to successfully go around in the vertical loop of 40 meters? So if the loop is 40 meters, that means the radius is 20 meters. They don't give you the mass, and let's see why the mass is not given. So all the way on the top, again, here is the motorcycle, and I'm going to write the forces acting on the motorcycle again. So the normal force is acted from the top of the loop. The force of gravity is acting on it. And I have centripetal acceleration because it's a circular motion. And I'll start again. So the sum of all the forces called the net force. And in our case, the net force is the centripetal force. We don't have to write it, but we have to remember it. And that is equal to MA. And in this case, again, it is centripetal acceleration. So again, I'm going to use this formula when I do my calculations. At first, I'm going to write the net force. So it's a negative normal force pointed down, negative mg. So this is my net force. This is my net force, two forces, equals to negative MAC because AC is also pointed down. So I have that. And when they say barely makes it through the top, that means all the way on the top for a split second, the normal force is going to be equal to 0. So it's the first moment when it feels almost like it barely made it. So the normal force is equal to 0. So I'm going to throw this away. Now what I have left is negative mg is equal to negative MAC. And this is why the mass was not given. I can cancel the mass from both sides. I can multiply both sides by -1. So UAC is equal to G. And UAC is V squared over R. So what I have, the V is the part that I'm looking for, squared. The radius is 20. And G is 10. So the velocity necessary to make it through the circle must be the square root of 200, or 10 square roots of 2 meters per second. Here's another question, and it doesn't matter whether your motorcycle is going in this kind of loop or your motorcycle is going in this kind of loop. I'm going to show you a different example with the second loop, not the first one. The first one we just solved similar. I'm going to show you an example in this loop. So if your motorcycle is right here, and what speed would it have to have, the 200 kilogram motorcycle, be driving in order to feel weightless on top of the 20-meter vertical loop? So the radius is 10 meters. And again, as always, I need to see my forces acting on the motorcycle. So I have the force of gravity, I have the normal force, and I have centripetal acceleration. It's not the force, it's just an acceleration. So the sum of all the forces, the sign of the sum, is equal to MAC The forces are normal force minus mg and equals to negative mac. They said the object would feel weightless, and weightless means there is no normal force. The object does not feel the force acting on it, but it's like falling down. Again, if I cancel the masses from both sides, multiply by -1 both sides, then I have AC is equal to G. AC is V squared over R is equal to G. So your V must be equal to the square root of R and G. And R is 10 meters. G is 10 meters. So the velocity needed is 10 meters per second. Anything less, he will not feel weightless. Anything more, he may fly off the track. Here's one more question. It's not a vertical circle, it's a horizontal circle. A toy plane so the string is 5 meters long string. So the radius, this is your radius, 5 meters long string. In a circle with a velocity of 10 meters per second, how quickly is the airplane accelerating as it changes its direction? So when they say how quickly accelerating, they're looking for centripetal acceleration. So centripetal acceleration is equal to V squared over R. Then give you velocity, which is 10 squared. And the radius is 5 meters. So that gives me 20 meters per second squared. And for the B part, if the tension of the string is 4.2 newtons, how massive is the plane? So for the B part, I have the centripetal force is equal to MAC. In this case, your centripetal force is your tension force and equal to MAC. So they give me the tension, which is 4.2 newtons, equals to the mass times acceleration, and I just found acceleration, centripetal acceleration is 20. So the mass of the airplane must be 0.21 kilogram if I divide both sides by 20. There are more questions online that you should practice before you take the assessment that I'm going to give you later. So you want to practice as many questions as possible so you do well on the assessment. And I'm going to also add the links to the previous video if you have not watched the previous video yet. Then thank you for watching. See you guys next time.